Hey Maria, why do we have daytime and nighttime?
Good question, Manny, and you're not the first to ask. This question has been asked since ancient times. It's helped drive scientists to study astronomy, a topic about objects in space. Today, we have the answer, but it took us almost 2,000 years and many hard-working minds to piece it all together. Let's start at the beginning of the story, with the ancient Greeks. In the 4th century BCE, the Pythagoreans, who were students of a mathematician named Pythagoras, believed that in our solar system, the Earth orbited or circled around the heavens, which are the sun and stars.
BCE? What does that mean?
BCE stands for Before Common Era, so the time period after what we consider Year 1.
Wow, the study of astronomy is extremely old.
Right? The theory of Aristotle, an important philosopher and scientist, overpowered the Pythagorean people. Aristotle believed that the opposite of what the Pythagoreans believed, that the sun and stars orbited the earth instead of the other way around. This is called a geocentric model. Geo means earth, and centric means at the center.
So Aristotle believed that the earth sits still, while the sun and the stars orbit the earth?
Yeah, Manny. According to the geocentric model, the earth sits still, so day and night occur because the sun moves around the earth. Some astronomers, like Aristarchus, were still not convinced by Aristotle's explanation. In the 200s BCE, Aristarchus built upon the ideas of the Pythagoreans and tried to popularize a heliocentric model. Helio means sun. In a heliocentric model, the Earth and the other planets orbit around the sun. However, Aristotle's geocentric model was still the most widely accepted one for many centuries to come. Ptolemy, a Greek astronomer who lived in the 100s CE, cemented the popularity of Aristotle's geocentric model by publishing a comprehensive astronomical text, meaning the most complete and detailed text at that time. His model is also called the Ptolemaic model, named after himself. The Indian astronomer Aryabhata in 499 CE was the first to say that the Earth rotates or spins in place. There is debate about whether he believed in a geocentric or a heliocentric model of the solar system. However, the fact that the Earth rotates about its own axis is crucial to our investigation of night and day. Without this piece of information, a heliocentric model would be unable to explain why we have night and day. Think about it. If the Earth orbited the sun without rotating, the same part of the Earth would always be facing the sun, meaning that half of the Earth would always have day and the other half would always have night.
Oh, so the Earth has to rotate on its own axis for people on different continents to have day and night. I get it.
Exactly. It was not until the 1500s CE that the heliocentric model would again have significant public support. Nicolaus Copernicus, drawing on the work of the Pythagoreans and Aristarchus from over 1,000 years before, formulated his heliocentric Copernican model in 1515. However, he did not publish his theory until almost 30 years later in 1543. Knowing that it might cause controversy, scientists were committed to the Ptolemaic model. The Copernican model turned out to be so influential that many historians would later say that it marked the start of a scientific revolution in Europe.
Wow, Copernicus's work started a whole revolution?
Yeah, it was the turning point for astronomy. After the death of Copernicus, astronomer Tycho Brahe used on his findings and continued researching, becoming famous for his extremely accurate measurements. He later teamed up with Johann Kepler, another astronomer and mathematician. Kepler used Brahe's data to develop his laws of planetary motion, which we still use today. Galileo Galilei, who lived at about the same time as Kepler and Brahe in the 1500s and 1600s, was the first person to use a telescope in his astronomical observations. He built the telescope he used himself. Based on his research, he became one of the most important advocates of a heliocentric model. His support for the heliocentric model caused a great deal of controversy among scientists and with the church. As a result, Galilei was placed on house arrest. He still continued his research, though.
He got in trouble with the church and kept pursuing astronomy? He must have been very passionate about his work.
Of course he was. He never gave up. After Galilei passed away, Isaac Newton, who was born in 1643, used Galilei's research to theorize about the laws of motion and universal gravitation. He eliminated doubt about the truth of the heliocentric model, proving that Galileo's research was true.
Oh, so I think I get it now. The heliocentric model, stating that the Earth orbits the sun, and the rotation of the Earth around its own axis creates night and day?
You're exactly right, Manny. It took humanity nearly 2,000 years of rigorous scientific research to understand correctly why we have night and day. As a result of all that work, we know that the Earth rotates while it orbits around the sun. The rotation of the Earth is the cause of night and day.